7 over x equals 2.
Yeah, very good. Actually, the way I'm going to say to do it, though, is, well, let's see. We know slope is rise over run, and we're given the problem, we're given the rise and the slope, and we want to find the run, right? Now, we could write this as an equation, that we put 2 here, we could put 7 here, and solve for this, right? What I'm going to do instead, I'm going to say, okay, well, if we have this, we can multiply both sides by run. So we get slope times run equals rise, right? As long as the run isn't 0, and somebody encountered that, it means you have an undefined slope, okay? Make sense? Or we could say, well then, we could say that run is rise divided by slope, right? Divide both sides by slope, you're going to get run equals rise divided by slope. Just using your basic, very simple algebra. Okay? So this one definition that everybody knows perfectly well can be expressed in 2 different ways. One way tells us what the rise would be if we know the slope and the run, right? The other way tells us what the run is if we know the rise and the slope. Now, which situation do we have here?
You have the rise and the slope.
Okay, well, we've got the rise and the slope, so we're trying to find the run, right? So we can say it's not rise times slope, it's rise divided by slope. The writing made no sense. Okay? Should be 2 over 7. So what I'm advocating is you first, when you see this and you're given a question of this nature, solve this equation for the rise. You just multiply both sides by the run.
Wouldn't it be 7 over 2? Isn't the rise 7?
That's it. Wrong. Yeah, it's rise over. Okay? But what I'm saying now is take this and get the expression for the rise in terms of the slope and the run. And then, now that you have this, might as well go ahead and divide both sides by the slope so you get the expression for the run. So no matter which 2 things you're given, you've got yourself covered, right? Okay? And then kind of get used to what these things mean. Okay? Problem 13 is an average rate of change problem. It's applied to the depth versus time situation. Okay?